This is the Banana Data Podcast, a podcast hosted by Data IQ. I'm Trevani.
And I'm Chris.
And in our bi-weekly episodes, we'll discuss the good, the great, and the ugly of AI. If you're craving even more, check out our 15-minute Banana Bites discussions on Data IQ's LinkedIn and Twitter every Wednesday at 2 p.m. EST. Today, we're sitting down with a roundtable of data science and machine learning experts from Spotify, PwC, and Google Cloud. We'll be going behind the scenes of the data science industry and our roles as data science practitioners.
So Trevani, today I thought maybe we could go a little bit outside of our comfort zones as we like to do. I love talking to you all the time, but I've had enough of you.
Yeah, same.
Oh no, feelings mutual.
You were ready for that, huh?
Oh no, you flipped the script on me. But we've got some friends here today to chat with.
Yeah, I'm excited. We're going to have a good chat with some interesting folks that are across different parts of the data science pipeline, the data science space. I think it'll have a lot of interesting takeaways for people from different parts of the field altogether.
Awesome. Let's dive right in.
Hi, everybody. Yeah, this is Abdallah Musmar. I am a manager in a machine learning team at PricewaterhouseCoopers, known as PwC. So I have been working with the team for about two years. I'm a technical lead on machine learning specific projects. Most of the work that I do is between research and technical implementation. So I wear many hats. It's kind of a fun job and really exciting.
Hey everybody, I'm Sanjay Agravat. I'm a machine learning specialist for Google Cloud. I help customers with their journey of machine learning and artificial intelligence on Google Cloud. Prior to joining Google, I did a PhD and focused mostly on biomedical informatics. And I also have a background in tech and software development.
I'm Alex Simonoff. I'm a senior data scientist at Spotify. Prior, I was working in the financial industry doing data science, and then I moved over to tech in 2015, where I worked at Etsy and now at Spotify, doing a lot of work around product data science.
So we've definitely got a stacked crowd today. I'm a little bit intimidated here with the resumes that are going around. You know, we have such varied backgrounds, and the space of data science is totally non-traditional because there is no tradition in data science. So I'd love to hear from you guys. How did you get into data science?
When I got into data science, it was about 8 years ago. At that time, I was still kind of fascinated about business intelligence and was like working mainly with data warehousing and dashboards. And I did like get into that industry for a while and worked a few jobs there. I thought about like, moving myself to a different area because I just thought data science was going to be more exciting. And I felt that I can do it. But there was like a huge gap to fill. And it took years basically to get myself familiar with things. And the main reason why I got into it was that I felt that everything in my mind, like my concepts about the world and how the world works, like really aligns with this profession. I want to do something I really love.
I actually started in data science. My first time was way back in 2009. So I was at Emory University at the time. I found out about a data science mining competition from UCSD. So this was before Kaggle came about. The UCSD used to have these data mining competitions, and I thought it'd be fun to enter it and actually kind of compete with a friend of mine. And so I had a lot of fun doing it. I was mostly just self-taught at the time. Really, did not have a formal background in like stats or machine learning at that time. So mostly had a background in software engineering and whatnot. And so from there, I sort of really piqued my interest in data science. And then over the course of my career at Emory University, I sort of started working more as part of my actual job with researchers at Emory. And so like helping with them with scientific software development and whatnot. And so I got more exposure to more researchy type of problems, and that like totally fascinated me, in addition to like learning a lot more about computational biology. And so I think like the combination of being in that environment at Emory, working with the researchers and just having that exposure to data science really piqued an interest in me in getting involved. And then another thing was that I remember that back in those days, you kind of had to have a PhD to like do like the cool research projects. And so I remember like my manager, I was working on a project, and there was like a postdoc helping with this project. And he was like, well, when it came to the ML algorithm, it was like, if we could have the postdoc, go and do it, but I'd rather have him maybe capable. So it was like one of those things where I realized that if I really wanted to go deep into it in terms of career perspective, that I had to at that time pursue a different educational track. And so that sort of helped also to propel me in pursuing the PhD and other things like that.
So for me, it was a math background, and graduating in 2013 when every single job list that you'd look at for the top jobs for people graduating with math degrees was actuary. So I started down that path like a lot of people that have ended up in data science, working for an insurance company. And then I had taken a class in school about business analytics and data mining. So I had some very small tools, but then I started getting really into hockey analytics, trying to understand how all of that worked. So I started taking Coursera classes. I found out there was a data science team at the company I worked for. I threw myself fully into it because I was so interested in learning everything I could. And by the time that I got there, so a few years after 2009, it was no longer necessarily a PhD in order to get all of these jobs, but they were starting to accept master students. So I applied, got a master's from NYU's Center for Data Science. And so I've kind of been working off of this just passion for trying to figure out how everything fits together when it comes to data and kind of any domain that I'm interested in. Once you kind of get into it, it really pulls you along because you solve a puzzle, you get an answer that you think is really satisfying, and then that just kind of pulls you in a little bit further. So I'd say the data science thing just kind of, you get a little interested in, then you get very interested in, and then it's your entire life.
It's a funny thing to see the thread here between all of you in that we started somewhere else, but I like solving puzzles. I like trying out new things. And gradually I move into data science as also the field of data science kind of grows. And it's funny that, Sanjay, you mentioned the whole thing about needing a PhD back then. And Alex and Abdallah both were in different fields that are highly mathematic and more analytical, but yet you all sort of ended up in the same space. And I think it just speaks to how, data science is actually based on a lot of things that have been in practice for a long time, right? It's not like we're reinventing the wheel here. So I'm curious to know from you guys what you think will be new and interesting in our field moving forward, right? Are we doomed to just keep repeating the same thing and calling it something new? Or are there some developments out there that are really pushing the boundaries?
I think the things that you're probably a little bit intimidated by are the things that are probably going to be new. So that's where I think this field keeps going, and it probably takes on the people who want to explore things and want to try out, for example, algorithms that have to do with generative stuff. For example, in finance, for example, in tech, there is a lot of new algorithms that go with autonomous driving and stuff like that. So I just think that the growth is probably going to be more towards how to get AI to do a lot of grow the industries and basically maybe break some of the patterns that are already been there for a while. That's where I see it going. And that's the excitement of the journey.
From my point of view, I see automation as something that is really, really creeping in very fastly in machine learning. When I started, before TensorFlow was a really popular framework or even actually existed at the time. So I remember writing C++ code and running jobs on high performance computing clusters and writing CUDA code that would run on the GPUs. And nowadays, it's all handled for you by TensorFlow, these layers of abstraction, these frameworks that handle these things for you automatically so that as a researcher, you can be more productive. And then it's not just about the software, it's about the model architectures built upon that also have helped with this. And then when you kind of keep taking it a step further, there's the automation side of it in terms of things like AutoML that are becoming really popular. So actually helping to automate the model architecture side of it now. So it's in a sense, giving you a lot more ability to experiment and test ideas out.
I have a slightly less technical view of the industry. I think my role is inherently slightly less technical, and I'm totally cool with that. And we have our own concerns. And I think for us, what the focus has become in the past few years has been a lot more of coming towards these problems with an empathetic approach. So instead of just running an A/B test, seeing how it affects users, and then rolling it out or not rolling it out, we have user researchers we work with who ask users things so we can try to get better direction. And at the end of the day, we're trying to build a product that is not only enjoyable for people, but is something that excites them.
I love this idea of so much variety within the data science space and so much diversity in talents and attributes that each of us kind of hold from our backgrounds. I feel like many people have this vision of computer scientists or data scientists where we're just sitting behind computers all day, writing code in the dark and, going on Reddit and, making coding jokes or whatever. But I'd love to hear from you guys, like, what stereotypes do you break?
If you're good at programming and probability and that stuff, then, it's probably a really good card, to hold on to. But one of the things that I try to always break is to not be so fascinated by that and kind of be a little bit more business centric in my thinking. And the way that I'm thinking about is that all of the background work that it's done, I'm trying to think of how can it make the world a better place and how can it also benefit the business that I'm working with, and try to see where we can go from there. Make sure that, the people that are actually looking into this project understand how far it will go. That's one of the things that I really, really care about.
And that's the key, right? Finding that overlap between what's going to make the business money, but what's also going to make the world a better place. I feel like that's incredible. And that's a hard task to solve.
We talk a lot about how data scientists need to be multifaceted, right? They should know how to code. They should know some stats. They should also know how to talk to people. They should know how to translate, all of these things. And yet when we look at how the job market brings in new data scientists, there's this heavy focus on, what does your GitHub look like? Can you do this coding test in 2 hours? Can you rewrite something XYZ? It doesn't actually apply to the kind of work you're going to be doing. So what has to change in sort of the perceptions in order to start vetting data scientists that are actually bringing those qualities that Abdallah is highlighting here that are really important?
As a ML specialist, I work primarily with customers. And when it comes to the data scientists I work with, I think if I had to classify them, it would be like the business analyst persona, the person that knows the value of machine learning, knows a lot about SQL, knows what the data looks like and what type of experimentation they want to do with it, but not necessarily all the underpinnings of the algorithms behind the scenes and how it works. The software developers, the software engineers that also understand the value of machine learning, analytics, and whatnot. I get the opportunity and the privilege to be able to work with all sorts of customers coming from different spectrums, and I really try to meet them where they are and help them to get to wherever their objectives are.
I'm going to double down on everything Sanjay said. You're never going to find two data science roles that are the same. Unless it's two data science roles in the same company, they might be the same, but across companies, across industries, there are so many different needs. The places that I've worked, my past two employers, they're pretty large companies. So they had data scientists like myself who are kind of more on the business analyst side where occasionally maybe I'll do a clustering model or something if it has some sort of business case to it. And then there's also this other side where you have machine learning engineers who they are in TensorFlow all day coding things, spending all their time coding. And then there's research scientists who spend a lot of time coding and a lot more time at conferences and reading things and writing things. And I think having the view of all of the different data science jobs at my current company gives me an appreciation and also terrifies me when it comes to these startup roles where it says data scientist and we expect you to do everything from talking to clientele to implementing a TensorFlow model in production. So I feel like there are definitely different stages of data science job development in the industry. And so I think, there are definitely places that want you to do every single thing that a data scientist can do and more. And then there are other places where it's a little bit more specialized, where people like myself who are yes, I do know what a convolutional neural net is and how it differs from recurrent, but I can't code that thing by myself. So, I can have an appreciation for it. I can help them test their models because I understand how they work. But at the same time, I'm not going to be the person who goes in, codes that, like, if you put Java in front of me, I won't know what to do.
I just Google everything on Stack Overflow, if I'm going to be honest, right? Like, I think that's one of the recurring jokes, right? Is that half of the code in the world is just copied from Stack Overflow. I think what you're saying, Alex, I think it's a good point here that data science as a field is not limited to the role of data scientist. I want to ask Abdallah, as someone who interacts with people who are not in the data science space, how do you work on breaking down those misconceptions of what data science is? Because when I see these job postings for chief data science officer at startup with 3 other people, I can read it and tell that the people looking for this person have no idea what data science is. And so they've just taken all of the words that they know and put it into a job rec. I'm curious to know, I think, from your side, Abdallah, how do you communicate and break down those misconceptions of what your team or what people like yourself can do?
So the idea really is to take the solution and kind of present it in a way where I am not talking about data science anymore. I'm talking about how can we solve this problem. And that's what I personally do in the background. Like I keep most, maybe 90% of the technical work to myself. I'm more interested in making the conversation about how can we move forward, because we know that we have solutions right now.
It sounds like there's really a spectrum when it comes to data science, and we're not really trying to fit into one box.
When you think about machine learning, it's just it actually ends up being a really small percentage of the whole overall effort involved in the machine learning type of project or application, that there's so much more that goes around it. And it's a lot of data engineering. There's even, security and business considerations. And then there's like the deployment side of it. So like once you actually have developed a model and you've tested and validated it and then you deploy it to production, how do you then go about monitoring that and then making sure it's performing with the metrics that you have trained it against, and sort of kind of incorporating sort of MLOps or DevOps-ish type of mindset into machine learning.
Alex, I'm thinking about your trajectory from actuary to where you are now. How did you discover that part of the pipeline or that part of the spectrum that works for you?
When I initially went to get my master's in data science, my plan was to do machine learning. I thought, everyone wants to do machine learning. Like it's awesome. You have a lot of power. You have all the data. It's a lot of interesting problems to solve. And when I was there, I realized that wasn't what I enjoyed doing, which caused like a little crisis in me that said, am I less of a data scientist because I'm not building these big models, which are on the cutting edge? And so, yeah, I'd say that for me, what helped me realize what I actually want to do was trying different jobs. So, I did data science in the financial space. I wasn't a big fan of it. I moved to a different company. I enjoyed it there, but wanted to try something new. And then there's, you can land on a job and you think it's your dream job, and then you find out that it's not. And I think that that's okay. I think the most important thing to do is keep your mind open to everything in data science. And I think there are new jobs being created within data science. We have analytics engineers who they're basically engineering all of the data that we're going to work with, and they're also data science in their own rights. And we have data visualization data science at our company now. So there are all of these different things that you can do that are all data science, and they're all equally important. And so I'd say recognizing that it was a wide field and figuring out what I did enjoy and didn't enjoy helped me kind of direct myself towards where I wanted to be.
Yeah, I think it's interesting. It's like, I feel the field of data science is one of those where it's like really important, obviously, to know what you know, but also to know what you don't know and helping you to get to where you want to go. Because when you know what you don't know, which there's a lot of it out there in data science, you can sort of like figure out, okay, well, that's something I want to try. What's a project I can do to, learn more about time series forecasting or like image segmentation? Like, I think data science is one of those fields where there's so much content out there now that's popping up. And there's a lot of it's really, I think, easy to sort of become overwhelmed with everything that's coming out there. But at the same time, it's also helpful in that, you can say, well, this is a new area, this is a new method that maybe I want to go look into one day. And it's like, I think finding that sort of breakthrough where it's like, I have a really cool problem I could potentially try out on this, that will help me learn and be more efficient at it is like maybe a way to sort of attack it.
One thing I kind of want to add to this is that most of the roads to other professions are kind of paved and things are straightforward. While in the area of data science, because like it's a new field and there are multiple approaches to this in companies, I think sometimes there are people that kind of resist going all the way with data science and just feeling like maybe we can do things with like Excel, for example, or or just like do basic stuff and that's it. And the value that you're getting, and I get that, like the value, the return from this investment is not going to be that high. What a person can do is that basically approach their work in data science from their skill and try to see maybe like internally what I can work on to get me to the next level.
Yeah, certainly very true. Just like we're trying to teach models to learn, we're also trying to teach ourselves what we like and what we dislike. It's sort of just like when you get a p-value that's insignificant to what Alex and Sanjay were talking about before. I remember, having this conversation with students in the past about like, you're not just trying to get significant p-values, the absence of an insight is also an insight is like one of the things I used to say a lot. So knowing that you didn't like this part of your job, but you thought you might is also information.
We have just a little bit of time left, and I wanted to ask maybe a silly question. If you had, let's say, access to any data that you wanted in the world, anything, what would you work on?
I think it's interesting. Like, actually, I harken back to the days when I was in academia research. Like, I did a lot of work in computational biology and cancer genomics. I really see a lot of value in that work. First of all, like from the pure intellectual side of it, just applying computer science and machine learning to the biomedical domain, but also like the impact you can make with helping with the progression of understanding cancer better, cancer progression, and cancer diagnosis.
Let's say this is like utopia and I have all the data and all the resources I need. So I would like try to work on some kind of system where, you would identify the most people that need help in the world and try to reach out to them and find ways for them to get help with the most appropriate resources, like kind of a matching between who wants to help and who needs help, with the way that like basically the objective is to maximize social utility.
So I'm going to be slightly less philanthropic here.
Oh, no.
Good. I was waiting for someone to give me more of the like...
But not malicious.
Evil data. Oh, sorry.
Not malicious, but not like saving the world. So my problems are slightly smaller that I'm solving. So if I had, yes, with the caveat that Abdallah added, all of the data, all of the resources, including time, I have these like small pet projects that I plan out in my head, but I never actually do because time. So one of them is if I could get all of my sleep data for the past 10 years and try to figure out the right time for me to fall asleep so I actually feel rested. But then I'd also have to have information about like how rested I felt that morning. But if I had all that data, I probably still wouldn't listen to a model that tells me to go to sleep at 10. So I think instead, I'm a huge hockey fan. Like, diehard. I've got hockey sticks behind me. I've, been playing for 6 years because I like the sport enough to do it, which is nuts. But hockey analytics, there are lack of ability for us to measure things. Like, you don't necessarily know where somebody took a shot on the ice, whether they scored, whether they didn't score. But if I had a gigantic data set of all of the NHL data for the past, like, maybe even just 20 years, but heck, if it was 40 years, like, you wouldn't see me for 3 days.
It would only take you 3 days to parse all that?
Well, no, I'm just saying you wouldn't see me for 3 days, because for 3 days I would be mining. I'd find something cool, and then I would yell outside to all of my neighbors, hey, did you know this? So yeah, I think for me, like, what gets me really excited to do data science, and not that I don't want to solve world hunger, climate change, or anything else, but what gets me really excited to do data science are these, are data points that speak to things that I care so deeply about, even if it is something so personal and so innocuous to the greater world. So that would be me.
I love that. Hockey is important too. It gives people joy. And for a hockey player, you have surprisingly a good amount of teeth still. So.
Oh, I'm not a good hockey player. So.
Just a quick sort of takeaway. Where do you think we as data scientists and future data scientists or future people in this space can focus their energies in a way that is good and not actually causing more harm?
The focus right now has shifted towards we have to be conscious when we're introducing bias into our models. And I think that's not necessarily something that's taught in master's programs and PhD programs. There, I think we kind of optimize for this goal of performance. Performance regardless of whether or not the model that we're building is going to potentially have some positive feedback loop that excludes a protected class of people or even an unprotected class of people as of right now.
Yeah, I mean, I really agree with that. I think like when you think about when you're training a model, you're evaluating it, like building in the practice and the evaluation of it to look at various different factors to ensure that you aren't incorporating any bias in your model. I think that's something that should be at the forefront of people when they're developing these models. And I think on another side of it, the field has sort of warped and sort of become this sort of black box-ish type of modeling system with deep neural networks. And there's a lot of work going on in explainability into those systems, which is really important. You're going to see in time more progression on more advanced statistics and Bayesian type of modeling, I think, incorporated into models going forward. And I think, a lot of this stuff is somewhat gets prohibited because of computational resources required in doing these types of models. But like, we've got all these like great accelerators out there now that have really helped to get us to where we are. And I think with the accelerators and algorithms and the data that I think are going to help to even propel us further.
I'm thinking of a little bit of a different trajectory, but if I would personally had the chance to make a move, I would probably accelerate the integration of data science related activities into like undergraduate and graduate programs. The way I would think about it is that instead of, students putting years into homeworks and exams that maybe are not that practical, maybe they can know a little bit earlier what they're getting into and kind of know what they need to get into this field and be able to get there. And I think that universities are actually on board with this. Like, for example, the university that I'm doing my PhD in, USF, they actually started the Citizen Data Science program for their undergraduates. And I was one of the people who basically brought this program from the ground. And a few years ago, no one knew anything about data science in undergrads. Now there's like hundreds of them that know a little bit about it. So my idea is that basically prior exposure now is kind of necessary because it's not emergence anymore, it's maturity, especially because this field requires a lot of knowledge and practice. Focusing on that in an earlier stage would be highly beneficial for the whole field, for the whole data science community.
Yeah. I mean, I think at the center of all of this, whether it's considering Bayesian methods or education of just about data practices and ethics, or, the concept of bias and what that means to mine data in a specific way to avoid biases, we as individuals putting these checks in ourselves and having that at the forefront of our minds is always going to be important. But again, it's always easier said than done, especially when there's conflicting points of view or conflicting constraints. So it's definitely a very difficult question to ask, both now and for the future. So thank you guys for all of those contributions. It's been great chatting today.
Been a lot of fun hearing other folks' experiences.
This was really nice.
Yeah, thanks for having us.
That's all we've got today in the world of banana data. We'll be back with another podcast in 2 weeks. But subscribe to the Banana Data newsletter to read these articles and more like them. And we've got links for all the articles we discussed today in the show notes below. Until next time.